Okay, we're going to continue on with line fitting and finding best fits to data on a scatter plot. 8M6 lesson 9, determining the equation of a line fit to data. We are going to take today, we're going to look at one thing that we did in class today in lesson 9, and then talk about how do we best fit the data. Then we're going to do two more, and then we're going to find the equation of that line. Using techniques that we've known about for months and months. And then we're going to do two more line fits on different data that I found out on the internet. And then we're going to make predictions about that, using that data to make predictions about what would happen at different points on that scatter graph. We're asking different questions about the data that where the data points don't exist on the graph, but given a linear model that we create, we can make very good predictions. Okay, so let's get on with it and move on to our screen, our data screen here, and get going. Okay, so this is the data that you have from class today, and it's kind of interesting. We're talking again about crocodiles biting and how much force they could bite with. And now it's kind of crazy. I was just thinking about this and looking at this, and so we have this. Imagine you have just forget about math for a second, and you have this little 35-pound crocodile. You know, this is smaller than any one of you in class. Probably, you know, the average weight of anyone in your class is probably, you know, maybe 70, 80, maybe 100, maybe 110 pounds. I don't know, but these crocodiles are all like half your size. Little crocodile, maybe 3 feet long, maybe, I don't know, 2 feet long. But look at their bite force. Oh my goodness. This means that if something was this would be like putting a giant football player on top of you. If a football player, a big football player in the NFL weighs 300 pounds, and he got on top of you and he had some spikes underneath, man, that would really hurt. But that's what it would feel like, what these crocodiles can bite with. They can bite with a force that's almost the weight of a lineman, just kind of crushing down on, you know, a gazelle or on top of whatever they might be eating. So I just thought that was kind of interesting. And boy, look at these guys. These big alligators that weigh like as much as a football player. They may be, you know, 6, 7 feet long. They can bite with a force that's like, you know, half of a car's weight. Like that would be like a half of a car just sitting on top of someone. That would be the same amount of force. That's what it means to have a bite force in pounds. That means the amount of force that it would feel like if they were biting on something. Wow, big numbers. Okay, so now the exercise at hand is for us to figure out who out of these 4 students have the best fit line, because this data, these points are all, notice how these are all the same data points on every single graph. I'm just circling, you know, a set of them here. You know, these 2 are the same as these 2 and these 2. Those are all the same points. But we are trying to figure out whether Saul, Patty, Marissa, or Taylor does the best job of line fitting here. And so what I want you to pause and think about one of these. There's one that is the best fit for the line, and figure out why that one's the best fit. And for the other 3, why are those bad fits? Who has best fit? And then why? Okay, I assume you're back now, and let's see. Let's start with Saul, and I want to circle something about Saul's data. Look at what he's done for the low values, and look at what he's done for the high values. Do we think he has a good fit? And I think the answer is no. No. His line is too low. It's too low here, but too high here. See what I'm saying? So he's underneath the points over here, and he's too far above the points over here. So Sol, I would say no. Now let's forget about Patty for a second because I'm giving you a hint. She might have the best stuff. See Marissa's problem, Marissa's it's too high. Her line is too high everywhere. So Sol is not it. Let's change the color here. It's not Sol. It's not Marissa. And so now let's look at, let's go over here to Taylor. Well, Taylor looks pretty good here. It's good low, but it's too low for big x's. For big values of x, she's too low. So Taylor's out. Sorry, Taylor. Good try, but you don't win. You don't win the prize. Patty's line, on the other hand, it looks like it kind of goes through the middle here, goes kind of through the middle here, and up for these big values, she has some values up high and some values down low. So we think Patty, this is the good fit. Now, there is a mathematical way of finding this best line, and but it's something that we'll learn in high school or in your next round of algebra, maybe in a statistics class. It's pretty cool how you can actually mathematically use all of these numbers and then find the best fit line. But we don't do that here. We're just going to make good guesses, and that's pretty much good enough because we know that this line is probably a pretty good fit, and we can make pretty good predictions on it. So now we're going to go to phase 2 of this question, and we're going to ask the question is well, what is the equation of this best fit line? So how do we do that? Well, what is the equation of this line? And that's something that we've learned how to do before. All we have to do, and here's the key, and we'll write this in green. The key is to take 2 points on the best fit line and calculate M and B to create y equals mx plus b best fit line. Okay, so here's how we do it. So we're going to take 2 points on the best fit line. So that doesn't mean take this point and say this point, or this point and this point. It means we take we find 2 places on this line. And now what I'm going to do is I'm going to find 2 points that look pretty good, that are far apart. So look at this. We're going to take this one here. And this one's going to be 50, 300. Now again, it only has to be something on the line like this and this. Doesn't have to be one of these points. It's just got to be on the line. But let's go ahead and take this one up here. And we're going to call this one 350, 1300. And now I'm going to go about finding my equation of the line. Now remember, we need to find our m. Well, let me put it in a different color. So our m is equal to y2 minus y1 over x2 minus x1. Then we'll go about finding b. So our y2 is 1300. Our y1 is 300. This should all be very familiar to you by now. Our x2 is 350. and our x1 is 50. So we have 1,000 over 300. Wow, this is going to work out nice, which is equal to 10 over 3, right? Cross, 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 which is equal to 3.338. Well, let's just leave it as 10/3. I like 10/3. Now, let's find our b. So the way that we do that is we take y equals mx plus b. We take one of our points. Let's use the one with the smaller numbers here. And then our m is 10/3. Remember, we just calculated that. So 300 equals 10/3 times 50 plus b. 300 equals 500 over 3 plus b. So let me just multiply everything through by 3. I'm going to make this easy. We're going to multiply both sides by 3 equals 500 plus 3b. So 400 equals 3b. So b equals 400 over 3. So y equals mx, m is 10/3 x plus 400 over 3. So there's our best fit line. So let's estimate. Let's use this power and let's estimate the bite force for 500-pound croc. So here we go. Y, and we're going to put 500 pounds. So we're going to pretend 350, 400. This would be 450. It'd be 5. It'd be somewhere over here. We don't know, but we can use our formula to guess for any crocodile way out here. Big, heavy ones. So let's go. Y equals 10/3 times 500 plus 400 over 3. I'm just going to use a calculator at this point. And I'm going to say, I'm going to do this for you. And the answer is 1,800. So y equals 1,800 pounds of force for 500-pound croc. So this 500-pound croc can generate force that's over 3 times his body weight. Unbelievable. Unbelievable. So hopefully all this makes sense. This is all of this stuff in pink is stuff that we did in 8M4. The only key addition is that you needed to find the best fit line, which Patty helped us do, and then find 2 points on that line. And after we found 2 points that are on the line, any 2 points, then we could create our y equals mx plus b best fit line. So now what we're going to do is we're going to do 2 examples. We're going to do 2 examples, and we're going to build some models and then do some estimates. So here we got, whoops, what I need to do now is I need to, whoops, I'm going to take this line away. All right, you know what the answer is, but so I got this example from the web, and here's where I got it. I always cite my examples if I take them from somewhere on the web. I got it from cqeacademy.com, and if you want to go and see it for yourself, you can go type in this URL and you can go to this example. Now, what they have done is they've said, well, we've taken some data points when the temperature at this given beach was a certain temperature. Here it's 82, and then on that day we had about 100 visitors. One day it was 84, and they had 225 visitors. And notice, as it gets warmer, we can tell that there is this relationship that as it gets warmer, we do have more visitors. So we want to model the visitors to the beach as linear equation that is a function of temp. So our temperature is on our x-axis and our beach visitors is on our y-axis. And we want to see that, of course, as it gets hotter, we're going to get more people at the beach. Hot days, we like to go to the water. We like to go to the beach and visit the water. So what we need to do first, and I'm going to remind us, is we're going to create a best fit line. And then 2, we're going to use the line to write an equation. And then 3, we're going to, in this case, we're going to estimate the number of visitors when temperature equals 100 degrees Fahrenheit, right? We don't have data points for, this would be, 98 and this would be 100 degrees. We don't have a data point. We don't know where the data is. There is no data for 100. And so we can guess that there's going to be more than 600 visitors somewhere over here, but how many? So let's figure that out. Okay, and we'll do this in green. So what I want you to do is think about a best fit line here, and then I'm going to draw one that I think is the best fit, and then we'll talk about whether it actually is a good fit or not. Okay, so I want you to pause and try. Think about your best fit line, and I'm going to draw one. Okay, and this is really homework help. Let's just write that in. Homework help, homework help. So that means you need to pause the video, pause, and try. Okay, I assume you're back. Now, here's the line that I found. I think that this is a pretty good line if we start here and then go here. I think that's a pretty good line. We have, let's see, let's just kind of look at this and let's just see. We have, we have a cluster of data kind of right here, and we have one kind of right, and then we kind of have one up here. And if we look at like these two, and maybe we have 2 clusters of data. We can look at our low numbers and we can look at our high numbers. And we're kind of going through the middle. We have one down here and we have one up here, one a little bit down here. So we're kind of going through the middle of our data here. And up here, we have 2 high, couple low, probably a pretty good line here. All right. So I'm going to call this a good fit. Now what's our second step? So we've created this best fit line, or what I think is the best fit line. And then we're going to use this line to write an equation. So let's find 2 points. Well, here's a good point right here at 80, 75. It's got to be on the line. And the other point I'm going to choose is this one. I'm going to choose 96, and this is about 625. Right? Each one of these goes 75. Each line is 75. So this is about 1/3 of the way up. So this is about 25. So this point here again is 80, 75. And this point here is 96, 625. Now, I encourage you again, now that I have the numbers, I want you to write the equation. I want you to pause and try. This is a key skill. This isn't a skill that you absolutely need to have leaving 8th grade. It's how to use 2 points to find the equation of a line. So I'm going to let you pause and try it. Now, remember, we're going to find our M first and then our B. Okay, so now I assume you're back. And so M is equal to y2 minus y1 over x2 minus x1. And that's going to be 625 minus 75 over 96 minus 80. So that equals 550 over 16. And now I'm going to go straight to the calculator here and do the division and say 550 divided by 16. And that's about 34.4. And that's our M. Now I'm going to use this point down here to find our B. So we're going to plug this guy and we're going to plug this guy into y equals mx plus b to find B. Because we have our y and our x from this equation, and we have our m from this equation. This brings in m, and this brings in x and y. So our y here is 75. Our m is 34.4. Our x is 80 plus b. So 34.4 times 80 equals, this is 75. 34.4 times 80 is 2752. Plus b. So now we subtract 2752 from both sides and we get b equals negative 2677. So our equation given m and b is y equals 34.4 times x, our temperature in degrees, minus 2677. So now to estimate the number of visitors when the temperature is 100 is we just take our 100 and we plug it in for x. And we go, well, y is equal to 34.4 times 100 minus 2677. And we get y equals 763 visitors when temp hits 100 degrees Fahrenheit. Now let me ask you another question about the data. And it's kind of an advanced question, but do we think that this is a good model at all temperatures? Well, it's good, it's nice and linear right here. Do we think it's going to work at all temperatures? And let me give you a hint. Think low temperatures. Think low temperatures. Do we think that this model is going to work? And well, let me put down some happy cats here. Let's give ourselves a happy cat for this best fit line, a happy cat for finding our slope, a happy cat for finding our B, a happy cat for finding our equation, and a happy cat for estimating the number of visitors when the temp hits 100. And now back to the question. Do we think this is a good model for really low temperatures? And the answer is, think about what happens when x is 0 degrees. It's 0 degrees, how many visitors are we going to get to our beach? When it's freezing, it's way below freezing. Well, our model would say that y is equal to 34.4 times 0 minus 267 visitors. Y is equal to negative 267 2,677 visitors. Can that be? Can we get negative visitors to the beach? And the answer is no. No. So the answer is the model is not good at very low temps. Okay, so this is kind of a little bit beyond this question, or maybe not. It's just very important to realize that sometimes line data can fit a line really well for certain distances or certain parts of the curve or certain parts of the scatter plot, but aren't really good at extreme ends. So you always got to be careful with these models that we're building. Got to be careful at extreme ends. Okay, let's do one more. And this one is similar. We're back at the beach. We're back at the beach. But notice this time we're talking about temperatures in degrees Celsius, not Fahrenheit. Okay, we're not really familiar with degrees Celsius in the United States, but if you're overseas, you're going to be very familiar with degrees Celsius and maybe less with Fahrenheit. And so this is the sales of ice cream sales at beach at various temperatures. Now, what I'm going to do here as well, I'm going to take this and we're going to make the line go away for a second. Okay, so now we have this data, this scatter data, and we want to, the question is this. The question is, is there a correlation between the temperature and the sales of ice cream? And I think you can see that the answer is yes. The lower temperatures have a lower sales, and the higher temperatures have a high sales, and medium temperatures have medium sales. So the object is going to be to, one, draw best fit line, two, find equation of line, and then three, predict sales at 30 degrees Celsius. So we're going to say, if we keep going, out here, where do we think the sales will be when it hits 30 degrees Celsius? Okay, so let's draw that line. And now what I'm going to do is I'm going to draw the line for you by just getting rid of this guy. There's the line. So, and let's just look at the quality of this line. Let's look at our low data, kind of our medium data, and our high data, and say, yeah, that looks pretty good. Here, we're right down the middle. Here, it kind of goes through a few points. And up here, it's maybe a tad high. But we can't really twist our line and make it higher, because then it would really miss our high points. And we can't really make it go lower, because then it would be too high for these low points. So I think this yellow line, and in fact, this yellow line is the best fit. Is calculated using the advanced statistical formula that you haven't learned and we're not going to learn in this class. But this is, in fact, the best fit line. Okay, so now let's predict the sales after we calculate our line, our best fit line. So what I'm going to do is I'm going to take this point here, which is on the line, and I'm going to take this point here, which is on the line. And so I'm going to tell you what this point is. It's about, we're going to call it 24, and it's about 3/4 of the way up. So that should be 575. It's 3/4 of the way between these two lines. Similarly, this is 3/4 of the way between these two lines. So this point here is 12, comma, 175. Right? This would be 200. This would be 100. So this is about 175. And so we're going to do the same thing one more time. M equals y2 minus y1 over x2 minus x1. And then we're going to go about finding B. Okay, our y2 is 575. Our y1 is 175. Our x2 is 24, and our x1 is 12. And so we get 400 over 12, which is equal to 33 and a third. So it's really 100 thirds, and we can leave it that way. Let's just leave it 100 thirds. So that would be, remember, we divide this by 4, we divide this by 4, and we get 100 thirds for our M. Okay, now let's use this point here to find our B. So we get y equals mx plus b. We're going to take this, which delivers us our x and our y. We're going to take this, which gives us our m. So we get 175 equals 100 thirds times 12 plus b. Okay, so I'm going to get out my calculator, and I don't even need to get out my calculator. I can cross that, 4. So I get 175 equals 400 plus b. So subtract 400, and I get b equals negative 225. So my equation is what? Y equals m x plus b, which is negative 225. So let's take a rest here. Happy cat for our straight line, happy cat for our b, happy cat for our m, happy cat for our equation. And now let's predict the sales when we get to 30 degrees. So y equals 100 over 3 times x, which is going to be 30, minus 225, cross 10. These numbers work out nice. 1,000 minus 225, so that equals $775. Sales of ice cream when temperature hits 30 degrees Celsius. And that deserves a happy cat. So again, in summary, what is this lesson about? What did we learn? We learned that how to best fit. We continued our lesson 8 in creating best fit lines, but then we went one step further and used that best fit line to write an algebraic equation, because again, graphs are the same thing as lines, algebraic equations that represent lines. Same thing, just a picture representation. In another case, you have algebraic representation. And then we used our 8M4 skills to write an equation of the line, and then we used that line to make predictions back in the verbal model world so that we could explain, well, if the temperature gets a little higher, we predict that our sales will go up, or as our temperature goes higher, what do we expect? More visitors at the beach, right? Or as our crocodiles get bigger, we have this much more bite force. So we'll leave it there, and we're going to move along. We have 5 lessons remaining for the year, and we're gonna take this these scatter plots, and we're going to do a little bit different type of work, but we're going to stick with graphs and statistics and see what we can learn. Happy cat, happy math. See you next time with lesson 10.